Hello, fellow math enthusiasts and learners of mathematics. One question that I get really often is, how did people exist without having a clue about algebra like hundreds and thousands of years back? How did they manage? Or people today, how can people do algebra without having a knowledge of algebra? It's possible. In this video, I'm going to explain this a little bit. And we'll give you, I don't know, 3-4 examples quickly. So one way of learning algebra is by following steps presented in a textbook. Cool. And that works for some people, but equally important, if not more important, to be able to think through problems, events, just life, and then solving them by backtracking steps. These backtracking steps is a logical steps that humans have, and some animals may have. I'm really not an expert on animal behavior, but backtracking, as in, say, if a lion or some kind of carnivore in a hunting scenario comes across a track of prey, they may or may not be able to follow the tracks and backtrack on the tracks of a prey animal and find the animal. But more or less, hunters can do this to some degree, but humans can systematically backtrack steps in life as well as in calculations, so including calculations. So, for example, if you leave the cookies on the kitchen table and you leave your kids in the same room for 2 hours, cookies are going to be gone. And if you ask them, where are the cookies, they ate them. Okay, you can backtrack the steps and come to a logical conclusion, something like that. You can do this with numbers as well. Say 6 of the 20 cookies went missing, something like that. So I have a more algebraic explanation or example here with these two pieces of coins. This is a $1 coin on the left, and this is a $2 coin on the right. So here is how the algebra sentence looks like. The sum of two numbers is 3, or the value of these coins combined is 3. One of the coins is one more than the other. What are the coins? In other words, x plus x plus 1 are the two coins, and when you add them, x plus 1, they equal 3. That's your algebra sentence that you can write about this. Different flavors to the same problem, and obviously if you think this through, it's obvious that this is a $1 coin and this is a $2 coin. A different flavor to the same problem is two consecutive numbers add up to 3. X and x plus 1 are consecutive numbers. What are those two numbers? It's 1 and 2. You can think things through without actually writing algebra and solving equations. Here's another one that involves this triangle here. And this is an isosceles triangle, so that means that these two legs on the triangle have the same length and has a symmetry about it, indicated with this broken line. And the base of this triangle is 6. So the perimeter, that is the sum of all three sides, the perimeter of this triangle is 20. The shortest side is 6. How long are the other two sides, which are equal in length? Now, in an algebra book, you would, or the learners would, need to come up with this equation, 2x plus 6 equals 20, and solve it. You can think this through. Because if you replace the triangle with just numbers, this is the same story. So you have a sum of 3 numbers. The perimeter of this isosceles triangle is 20. So one of the numbers is 6. The other two are just equal legs or equal sides on the triangle. So how can this be solved? You start with 20. That's the perimeter. One of the known sides is 6. So you subtract the 6 from the 20. Let's see, what do you have left? you are left with 14 for the two sides. You have to split it equally. How about 7 and 7? This is backtracking, and in terms of writing up the equation, this is exactly what happens. So you subtract 6 from both sides, backtracking, you end up with 14, and with the two equal sides, 2x. And what you do after that is you split it in half equally, so divide both sides of the equation by 2, there x equals 7. Exactly the same problem with yet another flavor to it. How about kids? 3 kids have a combined age of 20 years when you add the ages of all 3 kids together. One of the kids is 6 years old, and the other 2 kids are identical twins. Again, how old are the twins? So obviously you have 20 as the sum of the 3 kids' ages, so you take away 6, you're at 14, and because these kids are twins, so they have the same age, 7 and 7, done. So this is how you can backtrack. This is how people have dealt with algebra, by being able to backtrack the steps that are laid out in the problem as the problem is being told. The problems are being told with telling you, say, a sum or whatever, a larger number, and then little details how they ended up with this sum. So you're just gonna have to follow it back and think things through. Just as important, if not more important, than actually being able to write the numbers neatly and doing the algebraic steps as per this math layout here. It's really, really important to think things through plainly before you do any of this. So that's what I wanted to share with you today. This needs practice, but everybody is able to do algebra.